Welcome to my projectbazaar.com. Let us discuss about the energy efficient clustering using correlation and random update based on data change rate for wireless sensor networks. Let us discuss about the abstract of the product. This paper presents an energy efficient clustering method using random update for wireless sensor networks. We divide the network into preliminary clusters depending on the temporal and spatial correlation of sensor data. These clusters are then updated by applying a timing update policy and cluster head rotation scheme, where the change of sensor data and energy ratio of sensor are taken into consideration to achieve the high energy efficiency and balance. The larger the change of rate sensor data in a cluster, so the higher rates is update the frequencies. So a sensor node that has a high data frequency is more likely to be selected as the head of its cluster. In the data transmission phase, a sampling rate control method is adapted to improve the efficiency of the data sampling. The experimental results indicate the proposed energy efficient clustering method using the random update method achieves a high energy efficiency and the energy balance. So the proposed work presents the WCRU, that is energy efficient clustering method using random update for wireless sensor networks. So that is depending upon the random and spatial correlation of sensor data to divide the network into the preliminary cluster, and then cluster are updated by applying the dynamic update policy and a cluster head rotation scheme. A sampling control method is adapted in the data transmission phase, that is finally the result, so that the proposed WCRU, that is a method achieves the high energy efficiency and the high energy balance. So in wireless sensor network usually contain a large amount of smart wireless sensor nodes that are small in size and operated on low power. Energy resources are often limited of wireless sensor networks, especially in certain applications where external energy supply is not available. Thus the energy efficiency become an emphasis of the research. So approximately the sensor node usually have the temporal and spatial correlation of sensor data. This results in the data redundancy. So that is 80% of the node power transmitting to the redundant waste of energy to the limits. Here we discuss about the flow diagram of the product. First of all, let's start. So initialize the cluster construction. There is a cluster will be construct, and then need to update. There is a need to update SS. Update the clusters. Otherwise, no. That is a update of clusters, and then the data transmission finally end. So update of clusters is a dynamic period. So again, the process will be initial cluster constructions. So this process in this section, the proposed of WCRU algorithm is firstly described, and the theoretical analysis indicates that the random update method will achieve the longer network lifetime, restricting the advantage of the proposed method. So this algorithm contains two stages. Normally that is an initial cluster construction, that is an ICC procedure, and the update of clusters procedure. We place a greater emphasis on the UC procedure, which is critical part of the whole algorithm. So in the ICC procedure, described of a correlation based clustering algorithm is used to construct clusters, whereas in the UC procedure, initial cluster can be adjusted by the random update method. So that is a dynamic period, it's randomly updated. The update frequency is determined dynamically by the nodes data change, so the rate within the clusters. By combining the cluster head rotation scheme with the random update method, we can select the proposed node to be in the particular network energy balance is achieved. In the data transmission phase, that is in this algorithm, the WCRU algorithm controls the sampling rate of each node to improve the transmission efficiency and guarantee of the network reliability. So the framework of the algorithm is this is a framework of the algorithm. So first of all, it's corresponding to the core algorithm used in the each step. So first of all, initial cluster constructions, that is in order to reduce overall data volume, we divide the network into initial cluster depending on the data temporal and spatial correlation. So enlightened by the coding of theorem, we use the average entropy to measure the correlation in this paper. So the consider distance and the data transmission amount to make the clustering performance optimal. So the nodes within the same cluster are highly correlated to the data or redundancy and can be effectively eliminated. So this approach constructs a reasonable topology. So that is a initial cluster construction, that is need to reasonable topology with the basics of reduce the overall data volume. So the average entropy describes the average data rate from every node, that is NSI, to create the center node Ni. It measures the capability of being a cluster head, which decrease of energy entropy. The correlation between Ni and its neighbor it's to be increases. So that is a small value AHS implies the small data volume. The energy consumption in a cluster is minimized. So in form of the joint entropy can be described by the mutual information. So next is update of clusters. In this section we present the details of update of clusters procedures in the WCRU algorithm, including the random update method. So that is a dynamic period, the cluster head rotation, and the node of sampling rate control schemes. Before the description of alters a procedure, the definition of data change rate, which is a key variable in the procedure, is introduced. The proposed update cluster procedure uses the rate of data change to describe the activation of sensor nodes. That is, information theory entropy is the expression of disorder to uncertainty of the system. When a sensor is inactivate, the data is stable and uncertainty. So the sensor is slow, leading to a small change of entropy on the control. The active sensor flexes greatly and entropy increases. So in this paper, the change of rate sensor is defined as the function of change of entropy. So such a function between zeros and ones. So between the value being widely applied in the computing the activation of neurons in neural network models. Finally, the data transmission. So in the data transmission, after the update of cluster procedure, CH nodes can represent the data feature of its clusters. So that is, the CMOM nodes do not need to report their data continuously. So the communication cost is very reduced. So however, the sensor data will change greatly when some imminent events occur, such as a fire disaster, gas leak, equipment fault, etc. So if these sensitivity data cannot be reported promptly, it will do the damage. The whole system will be damaged. We define the above situation as sampling rate problem. In this paper, the sampling rate means that is a time interval between the reports and the data samples by the sensor. So facing the problem, we adapt a node sampling rate method to control the adjust and data report frequency as the flow. So these are the flow diagram of the product. Yeah, here we discuss about the running procedure for the product. Click the main file and run. So under run, so there are so many outputs or displays. So in this first output, so this is the first output. In this first output, so yeah, this is the first output. In this first output, there is a sensor node deployment. The greens are declared there are 100 number of nodes, so that is a sensor node deployment. So x-axis is 0 to 100. Similarly for y-axis is also at 0 to 100. So these are the sensor node deployment. So this figure shows the node deployments in the 100 nodes or in the system. So next figure is, yeah, this is the next figure. In this figure, so in this figure, this is a cluster formation. So cluster formation means the greens are nodes, so black and pink and yellow, blue. So these are the cluster formation of the system. So 0 to 100, there are 100 nodes. Here also there are 100 nodes, and this is here cluster formation of the many clusters are designed. So the black and pink and also the different types of nodes are creating. So this figures are shown as a cluster formation. And the third graph, so in this third graph, so this is the third graph. So in this third graph, is a cluster updating. So in this cluster updating, the nodes are updated related to our flow diagram. So the nodes are updated. The black, blue, pink. So all the colors are updated. So this figure is shown as a cluster updating. Yeah. So next figure. Similarly, the next figure. So this is the next figure. In this figure. Yeah, so in this figure, the x-axis depending upon the time label, and this is total residual energy. So this is the random update. So random update is linearly high. So this is a green clustering process denoted as a green color. So this graph is shown the comparison between the random update method and reclustering scheme. So this is the process of random update and reclustering scheme. So the next graph is shown in this figure. So in this figure, this is a comparison of network lifetime of WRCU, this is DDCD and leech. So these two both are existing results, and the green one is a proposed method. In this proposed method, the x-axis is the time label and the y-axis alive node numbers. So alive node numbers is 0 to up to 80. So compared to existing method, our proposed method is increases. So the next figure is this is the next figure. In this next figure, the network residual energy distribution of statistical histogram. So this blue color index are proposed, and green and brown indicates are existing. So in the x-axis distribution range of residual energy in percentage, and the y-axis is the number of nodes. So 0 to 35 nodes. Blue is indicator of a proposed method, and other both are our existing methods. So the other graph is. This is the last and final graph. In this final graph, Network history energy distribution statistical histogram, that is a percentage of sampling time, detection ratio of sensitive data. So compared to this, so this too is WCRU, that is a proposed method. This is a DCD, so this is a DCD, and this is a leech. So compared to all this, our proposed one is a high. So this is a percentage 0 to 100 percentage. That is a network history and energy distribution of the statistical histogram. So these are the running procedure for the product. Thank you for listening this video.